From the previous video, we learned logistic regression. In this video, let's explore softmax regression. First, we'll discuss what is softmax regression and how to calculate the softmax scores. Second, we will explore its cost function and gradient vector. Third, we'll dive into the practical example and learn how to use it. Lastly, we will briefly explore the softmax function in the last layer of large language model transformer architecture. Without further ado, let's get started. Softmax score is calculated by this formula. Simply multiply the instance and the parameter vector theta k. K is the number of classes. Sk is the score of each class for instance x. After we calculate the score of every class, we can apply the softmax function to estimate the probability that instance x belongs to class k. The softmax function computes the exponential of every score, then normalize them by dividing the sum of all exponentials. This is a function of the softmax regression classifier. This function outputs the value of k that maximizes the estimated probability of softmax scores. The objective of training a softmax regression model is to output a high probability for the target class and low probability for other classes. This is a cost function for softmax regression. This function is often called cross-entropy cost function. When k equals to 2, this is the same as logistic regression cost function. And this is a gradient vector of this cost function with regarding the theta k. Now we have gradient vector for each class, and we can apply the gradient descent algorithm to find the parameter matrix that minimizes the cost function. Let's move to the practical example. We are going to use the same dataset from the previous video. First, load the dataset and feed the data to train the logistic regression. Sk logistic regression default uses softmax regression when we classify more than 2 classes. We use a mesh grade function to populate datasets. Then we can use our trained softmax regression to populate the predictions. The contour prop 1 stores all the probability of index 1 from the softmax output probability array. This index 1 means the probability of vaginica flower. Then, we use a contour library to draw the line and connect the same values predicted by the softmax function. As we can see, the softmax function clearly separates the 3 targets into 3 different areas. For those data within the inner green line, the probability of vaginica is larger than 90%. Lastly, let's check out this picture of transformer architecture. The very last layer is a softmax function. When the transformer generates words, after all the previous steps, there are multiple candidates for the next word. The softmax function is applied here and converts the score of those candidates into the probability. So the model can use a higher probability of the candidate and make it as the next word. This ends our video. Thanks for watching. If you found this video interesting and learned something, please consider like and subscribe. See you in the next video.